Hello guys and welcome back to my channel Interview with Bunny, and today we are back with another video on our system designing playlist, and the application and the system that we will be designing today is called the hotel booking system. So it's more like Airbnb, booking.com or Make My Trip, where the user will have the ability to search for a hotel at a particular location and then book a room at that hotel. So this is basically the system we have to design in our system designing round. So as I always tell you that the system designing round is a very vague interview round where the interviewer will give you a very open-ended question like design a hotel booking system, and it is your duty to understand that what is the functional and the non-functional requirement and what is the actual core concept of the system that you have to design. So without wasting much time, let's get started with today's video of designing a hotel booking system like Airbnb, Make My Trip and Bookings.com. So let's start with the first step of our system designing round, and that is the requirement gathering. So since you guys are already familiar with the hotel booking system, so discussing the functional and the non-functional requirement with your interviewer will be pretty easy and straightforward. Because since here the problem statement is very straightforward and simple, so here we have only some of the handful number of requirement that we have to fulfill. So the functional requirement of the system will be pretty straightforward. Number one, user should be able to log into our application. Number two, once the user lands to our application, he should have the ability to search for a hotel based on few of the criteria like the location of the hotel, the name of the hotel and so on. And number three, once he finds a hotel, he should be shown with all the hotel details and he should be given with all the rooms that are available on a particular date. And based on the criteria, that is the location of the hotel and the date of the booking, we have to show the list of rooms that are available on that hotel. And if the rooms are available for booking, he should be able to book a particular room and he have to make the payment. And once the payment is done, the next requirement is he should be able to see all the past bookings that he have made. So these are pretty much the simple straightforward requirement that we have to fulfill. So let's first list down all the functional requirements over here. So here you can see these are all the functional requirements that we have to design for this system. So these are mainly the 5 requirements that we have to fulfill. Now since we have got an idea that what will be the functional requirement, let's now see what will be the non-functional requirement for this system. So the first non-functional requirement that you have to discuss with your interviewer is the scale of the system. Means you have to get an estimation that for how many numbers of users you are building the application, because based on that number you have to take some critical decision while designing this system. So here the interviewer might tell you that since we are creating a system that is available globally, so we are targeting about 15 million users, and the total number of listings or the hotels that are available in our system is around 1 million. So here you can see this is a huge amount of data that we are talking about. So here we are targeting 50 million users and 1 million hotels. Now let's go to the next important non-functional requirement for our system, and that is the cap theorem. And as I have discussed in my previous videos also, cap theorem tells that whenever you are creating a distributed system, it is not possible to implement both the high consistency and high availability on a particular module of the system. So you have to either compromise with the high availability or you have to compromise with the high consistency. But here if you look carefully in our system, we need both of them because our system should be highly available, otherwise user won't be able to book the room through our application, and also our system should be highly consistent, otherwise it might can happen that two different users are trying to book the same room on a same hotel on a same date. So our system should be highly available based on searching, and our system should be highly consistent based on the booking. So here what we will do, our application should be highly available based on the searching, and our application should be highly consistent based on the booking of the room. Means no two users should be able to book the same room at a given date. So these are the two most important non-functional requirements that we have to keep in mind while designing this system. So I think we are done with the first step of our system designing, and that is the gathering of the functional and the non-functional requirement. But remember, since this problem statement is very simple and very straightforward, so our interviewer will expect we design our system in detail so that we can fulfill each and every functional as well as all the non-functional requirement of the system. And keep in mind, this point that we have mentioned in our non-functional requirement is very crucial. That is, we have to design our system in such a consistent way that no two users should be able to book the same room. So without wasting much time, let's get started with the second step of our system designing, and that is identification of the code entity. So here, based on the functional requirement, you can easily identify the code entity. So the first code entity is obviously the user who is actually booking the hotels. Number 2, the hotel. Number 3, the rooms of the hotel. And number 4, the actual booking system. So these are primarily the code entity that we have to focus. Now, since we have identified the code entity, now let's go to the next step and one of the most important steps of our system designing, and that is the API creation. So as I always tell you, designing the API or the REST endpoint are very easy if you have done the requirement gathering properly. Because in most of the time, API designing have one-to-one mapping with the functional requirement. So let's see what will be the API endpoint that we need to design this application. So here, if you look at the first functional requirement, here the first requirement tells that we have to provision our application in such a way so that the user should be able to create an account in our application. So here the first endpoint that we have to provide for the user, that is the sign in and the sign up. So here we have to open a REST endpoint by which user will be able to register within our application. And since we are submitting a data in our system, so obviously this will be a post call. So here the first endpoint will be the post endpoint, and it will be for registering a particular user. So this is how our first endpoint will look like. And since this is a post endpoint, so it should obviously have a body of the request. So the body of this request will be the user metadata. For example, the name of the user, email ID, the password, the phone number, all those things comes under the user metadata. So this will be the first endpoint for registering a particular user in our application. But along with this, there should be some additional endpoint to handle a particular user. For example, when the user will be logging in, there should be an endpoint for login, logout, update, and all those things. So here we will not go in detail on each and every endpoint that we require for handling a particular user. Rather, what we will do here, we will simply mention that we need some additional URL for login, logout, and update. So that's it. So here we will not go in detail of creating the signature of all these 3 endpoints, because remember, during your interview you only have 45 minutes to 50 minutes to design this entire application. And if you are wasting your time in designing all these auxiliary services which are not the core entity or the main requirement of our application, then you will not get enough time to design the real core concept that the interviewer will be looking for. So here, just keep all those things and just tell the interviewer that along with this signature, I also want that there should be additional API endpoint so that the user should be able to log in, log out, and update. And that's it. This is the only thing that you have to do during your interview. Now let's go into the next endpoint to fulfill the next functional requirement, and that is the user should be able to search a hotel based on the location and name. And since here user want to retrieve the information from our system, so obviously this will be a get endpoint. And let's see how the endpoint will look like. So here we will be having the search query where you have to pass the name of the hotel if you know, otherwise you can keep it blank. And also you have to pass the location where you want to search the hotel. So these are the 2 open parameters that a user can give to search a hotel. And since there can be more than one search result over here, so here we are returning a list of hotel ID. And here instead of just sending the hotel ID, here you can send a partial data. Means here you can send some of the metadata of the hotel, means the thumbnail of the hotel, the title, description, review, all those things can come in the search result. And here, since this list can be huge, so obviously you have to send the entire result in the form of the pagination. Otherwise, for example, for a particular search result, you get thousands of record in our database. Now, if you send all those thousands record to our front end will take a lot of time to render all those things in our UI, and that will increase the latency of our system, and it will be a very bad experience for the user. So here we have to see that the latency of our system should be very optimized. And along with this, I forgot to mention one thing, that is here along with name and location, you also have to send the date on which you want to book. So here there will be another search criteria, and that is the date on which you want to book a particular hotel. Now let's go to the third endpoint of our system to fulfill our third requirement, and that is users should be able to book a room in the hotel based on the availability. So here what we have to do, once the user find a hotel from this search result, we have to show all the metadata of the hotel, means description, what are the amenities that are present, what are the rooms that are available in our hotel, all those detailed list of description we have to show to the user once he selects a particular hotel. So here to retrieve all those metadata, we need our third endpoint, and that will be obviously our get endpoint, and it will look something like this. So this will be our third endpoint where we are trying to see all the metadata of the hotel, and we are also sending the date of the booking, because obviously remember, though all the information of the hotel, means the hotel metadata, will be same for a particular hotel, but the list of available rooms might vary based on the dates. So here we have to pass the date of the booking so that we can see what are the rooms that are available on that corresponding date. And the return type will be all the description, amenities, review, all those things. Along with that, we have to send all the list of the rooms that are available along with the price on that particular date. So here remember, price attribute of a particular room can vary based on the date, and that is why here we are sending the date as one of our parameters, so that when we will be searching in our database, we can see that what are the rooms that are available on this date and what will be the corresponding price on that date. Now the next scenario is user should be able to book room of the hotel, and to support that we have to create our next endpoint, and this is how the endpoint will look like. So this is how our booking URL will look like. So here you can see we have the booking URL, where in the body of this request we are sending the hotel ID, the room ID, and the date on which we are trying to book. And along with these, we also have to send the user ID, means who is trying to book this hotel, in the header of this request. So this will be our booking endpoint, and this will return a booking ID, means a booking reference number. But remember, though this step looks quite simple and straightforward, but in real life this is not at all simple, because internally while you are booking a particular room, this booking service have to call our payment service, and the payment service will have to do all the payment related thing, and once the payment is confirmed, thereafter you will get the booking ID or the booking reference number. So basically this booking scenario is a two-step process, where you have to first book a particular room and then you have to make the payment, and once the payment is successful, then you can only confirm a booking of a room. But here right now we will not go in detail of all those things, because all those things we will be designing in our next section. So now let's see what can be the other API endpoints that are required for fulfilling our functional requirement. And the next functional requirement that we have over here is user should be able to see all the past booking in his profile. So here there will be last and the final endpoint, and that will be also a get endpoint, and the endpoint will look something like this. And that's it. Here you can see we are sending the user ID in our request, and based on this user ID, it will return all the list of bookings that he have done successfully in the past. So these are primarily all the major API endpoints that we have to discuss during our system designing, which almost fulfill all the functional requirements that we have gathered over here. Now since we are done with the three steps of our system designing, that is gathering of the requirement, identification of the code entity, and number 3, the API designing. Now let's go into the most important thing, and that is the high level designing of our application. And as you know, high level designing of the application is very simple if you have managed to do until this point. So let's see what will be the high level designing of our hotel booking application and how we will fulfill all the requirements that we have gathered over here. So let's move to the next section of our system designing, and that is the high level designing. So here if you look carefully into our core entities and in our functional requirement, the first primary attribute or the entity that we need in our system is the user entity. So here what we will do, here we will first define some user who will be actually using our application. Now if you look carefully into our non-functional requirement, you can see that the scale of the user for which we are creating this application is 50 million, which is pretty huge. So obviously here we have to go with the microservice or the distributed architecture rather than the monolithic architecture, because obviously it is quite clear that our monolithic application will not be able to handle this much amount of traffic and the load on a particular service and server. So what we will do here, we will go with the microservice architecture. And as you know, once we design a microservice architecture, one thing that we have to introduce, and that is the load balancer and the API gateway, so that this huge amount of traffic get evenly distributed along all the services that we have in our backend. So here what we'll do, we will introduce the API gateway and the load balancer over here. And the main functionality of this component will be authentication and authorization, routing of the user request based on the endpoint, number 3 rate limiting, and number 4 evenly distributing the traffic across all the server based on the round robin algorithm. So let's list down all those core functionality over here. And that's it. Here we have the load balancer and the API gateway to distribute our traffic. Now let's see what are the backend service that we need to fulfill all this functional requirement. And here, based on our functional requirement, the first backend service that we need is the user service. And the main role of this user service will be onboarding the user into our application. So here we will be having our first service called the user service. And here obviously, since the user will be registering themselves into our application, so we have to save all the metadata of our user in a particular database. And for that, what we will do, here we will be creating a database to save all those metadata. And here we will be calling it as user DB. And that's it. So here we have the user service and the user DB to capture all the metadata of the user. But what type of database we will be using, that we will be discussing in our next section, where we will go in detail on each and every service that we are designing right now. But in our high level designing, we will just abstract all our designing and we will try to only focus on the functional requirement that we have gathered at the very beginning. So here you can see all our users are coming into our application, and the request will first go into our load balancer, and based on the API endpoint, our API request will get diverted to our user service. And from our user service, what we are doing, we are simply saving the metadata of the user into our DB, and thus we fulfill our first requirement, and that is onboarding of the user in our application. Now the next service that we have to provide for our user is the search service. And for that, what we will do, we will create another service over here called as search service. And the main responsibility of this service will be, once the user requests particular hotel based on the name, location or the date, it have to scan to our hotel database and it have to fetch all the matching hotels based on the search criteria. So here what we have to do, here we have to provide a hotel database which will capture all the metadata of the hotels, means what is the location, where it is located, what is the name of the hotel, what are the rooms that are available. So all those details should be present in this hotel database, and the primary role of this search service will be to scan on that hotel database and to find out all the matching hotels based on the search criteria that user wants. So this will be our second service, that is our search service. Now the next service will be the booking service, means once the user get all the list of hotel and the front end, what is the next step? He have to make the payment and confirm the booking. For that, to make the booking, what we will do, we will create our next service, and that is the booking service. And as I was telling you over here, booking a particular hotel is a two-phase process. Means once the booking request comes to our booking service, he have to redirect the user to the payment gateway. And once the payment is successful, then only we can confirm that the booking is done. So here what we will do, from the booking service, we will call our third service, and that is the payment gateway. So here we will be having our next service called the payment gateway. And once the payment is successful, obviously we have to save that booking details in a particular database. So for that, what we will do, we will be having another database called as the booking DB, which will have all the information related to the booking. Now the last but not the least, we have to give the user the provision to see what are the past booking that he have done. And for that, what we'll do here, we will be giving one more additional service called as booking info service. And the main role of this booking service will be to go to the booking database and retrieve all the past bookings of a particular user. And the last but not the least, we also have to prove the provision, and that is submitting the review for a hotel. And for that also, we will be creating our last service, and that is the review service. And here all the review related data, you can either save it in a separate database or you can either save it in our hotel DB. That is completely your choice, but it is better to keep it separate. So here what we will do, here we will be having one more database to save all the review related information in a separate DB. So hopefully you have understood that how using this high level designing, we are fulfilling all the functional requirement that we have gathered at the very beginning. But if you look carefully, this designing is quite high level. We are not explaining in detail that how the user service will work, how the search service will work, how we will save all this metadata of the hotel in a particular DB, or we are not also discussing that how the booking will also happen. Because if you remember, while we were designing the non-functional requirement, we have clearly mentioned that we have to implement consistency in our service so that no two user can book a particular room. But here in this designing, we are not at all discussing all those details. So what we will do, we will go into in depth of each and every service in detail in our last section and the last step of our system designing, and that is the fifth step, where we will discuss in detail on each and every component, and we will see that how each and every component will work, how they will be correlated with each other, how we will optimize our database, how we will reduce our latency, and everything we will be discussing in our next and the final section, and that is the low level designing or in our deep dive designing. So without wasting much time, let's go to the last section of our system designing, and that is the low level designing. So let's start with the deep dive or the low level designing of each and every component over here. So the first thing what we will do, I will copy this entire high level from here into our next section. And let's now start with the first service, and that is the user service. So as you know, the user service is quite simple and straightforward, because here in this service, we are just collecting data from our user and we are persisting it in our user DB. So that is the only flow that we are doing. And whenever a user is logging to our application for the second time, then we are using it for the authentication by verifying the credentials like email ID and password. And if the user has been authenticated successfully, then we are generating the JWT token so that our user can call our subsequent API call. So that is the only responsibility of this user service. So here we will not do too much fancy. Only thing that we will be discussing over here is the database that we will be using for the user DB. So since user DB is highly a relational database, so what we will do here, we will save all the user metadata in a MySQL or in a Postgres database. So what we will do here, our user DB will be a MySQL database, and the metadata or the schema that we will save in our user DB is quite simple. That is name, email ID, user ID, password, and few of the metadata of each and every user. So let's see what will be the schema structure over here. So here you can see this will be the more or less the schema structure for the user DB. So this is quite straightforward. Now let's go to the next service, and probably one of the most important service, and that is the search service. So here if you look carefully, our search service is actually doing a lot of things, because here a user can search a particular hotel based on the name or the title of the hotel, based on the location, as well as based on the time range when he wants to stay. So here there are mostly three criteria by which user can search hotel in any location. But here if you look carefully in our hotel DB, this hotel DB consists of a lot of information regarding each and every hotel, because each and every hotel will have a lot of things. Number one, it will have the metadata of the hotel, means the title, address, amenities, all the textual form of the data. Number two, it will have the images of the hotel. Number three, it should have all the prices related to each and every rooms of the hotel. For example, if a hotel have 300 rooms, so obviously all those 300 rooms should have a price range on each and every day, because remember, the price of a room mostly varies from time to time, because obviously during some occasion or festival the price can vary accordingly. So here we also have to keep track of prices of each and every room, as well as there is one more important thing, and maybe one of the crucial thing, that is the availability of room, means on which day which of the rooms are vacant and ready to be booked by the customer. So let's see how we will store all those information about each and every rooms of the hotel in this hotel database. So let's see what we will do. So here, since all the hotel related data are relational with each other, means for example a hotel is related with all the rooms, similarly a rooms is related to the availability as well as price. So there are a lot of correlation between each and every attribute within a hotel, and that is why we will go with the Postgres database over here, so that the relationship between all the tables are also maintained and it can be scaled properly. So here what we will do, here we will be going with a Postgres solution. Now let's see what will be the tables that we need to persist within this hotel database. So the first and the foremost table that we have to create within this hotel DB is a hotel table, which will consist of all the textual metadata of a particular hotel. For example, the title, the geolocation, the hotel ID, the address, and all those things. So here we will create the first table, that is the hotel table, and let's see what will be the schema structure of that table. So this is how the schema structure of the hotel table will look like. So here we have a hotel ID, the name of the hotel, the address, means the textual address which we have to show to the user, and the actual geolocation address, which will consist of the latitude and the longitude, so that we can do a proximity search based on the search criteria. So here this will be the first table of our hotel database, and that is the hotel table. Now the next table that we need for this hotel DB is the rooms table, because each and every hotel obviously will have multiple rooms of different categories, and all those related metadata or the attributes of the room should be saved in our rooms table. So we will create the next table called the rooms table, and let's see how the schema will look like. So this is how the rooms table will look like, where we have a hotel ID, the room ID, the type of the room it is, means whether it is a deluxe or the standard room, also the capacity of the room, and all the related metadata that we need for a particular room. So this will be our second table, that is the rooms table. Now here, since we have created the hotel, which is the primary attribute, and the rooms that are present within the hotel, now the next thing that we have to incorporate within our design, and that is the availability and the price of the room. So the first thing that we will do here is the price of the room. And as I was telling you, each and every room will have a different price on different time frame. So our database should be flexible enough to handle different valuation of the room on different time frame. So let's see what will be the schema structure over here. So if you look carefully, this will be the schema structure of our price table. So here you can see we have a hotel ID, the room ID, because obviously we need a correlation between the room and the hotel. Next attribute is the price of the room and the currency by which it is saved. And now the next important thing is the start date and the end date of this price. So for example, during the month of the January, the price of the room is 1200. But on the February from 1st to 15th, it might be 1400. So in this way, we have to store the valuation of each and individual rooms in our database based on the particular date range, so that our design is flexible enough to handle all this scenario. So this will be the schema structure of our price table. Now let's come to our next table, which is one of the important table of our hotel database, and that is the availability of the room. Now, if you understand this complexity carefully, saving the availability of each and every room in our database is actually very complex, because remember, here we are just not saving the days on which our rooms are vacant or occupied. Also, our design should be highly optimized so that we can run search query on the table, because once the user is trying to search for a particular room in the hotel on a given time frame, we have to write down that complex query and we have to scan this entire table to find out the relevant rooms those are available on that time frame. So here the way we are saving the availability of the rooms in our table is quite critical. And here I will give you two approaches by which you can save the availability data in your database. So let me show you the first approach or the first schema structure to solve this problem. So this will be the first way of storing the availability of a room in the hotel. So here you can see we are storing the hotel ID, the room ID for which we are storing the availability data, next the date and then the status. So here if you understand this schema correctly, what we are actually doing for a particular room, we are having 365 records on a table, means we are taking a complete year calendar and we are keeping a record of each and every day that whether the room is available or not. So this is the first way of storing data. So this will be highly efficient for searching. But there is a small problem, that is you can easily understand that the amount of data that we are storing in our database is quite huge. Because for example, if a hotel have 300 rooms, then all the 300 rooms will have 365 days of record in our database. So it will be 365 into 300. That will be the total number of records in our database for a single hotel. So that is a huge volume of data that we are saving by this schema. And if you look carefully, we are dealing with 1 million hotel. So you can easily understand that the volume of the data will be quite huge. So this will be one of the approach, but believe me, this will be highly efficient for searching. But let me give you the second solution by which you can also save the availability data in our database. So let's go to the next schema. So this will be the second schema structure for saving the availability of the room. So here you can see we have the same hotel ID, the room ID, but here instead of saving the record for each and every date, we are saving a date range. So for example, for the first 6 months of the year, the price of a room is same. So what we are doing, we are only having a single entry in our database that for January 1st till March 31st, the price is 1200. And with this schema structure, we are actually saving a lot of volume of the data that we are saving earlier. So this will be the two solution by which you can save the availability of the data. But remember, maintaining this schema structure is a bit difficult because for example, here at the beginning of the year, for example, from January 1st to April 31st, your room is available for booking. But for example, a customer comes up and book a room for a couple of days within this time frame, then here while saving the data in our database, we have to manipulate the older data as well. Because right now your rooms are not available for all the 6 months. Rather, there is a time frame on which your room is available. Then for a couple of days it is booked and then for the rest of the month it is vacant. So in this way, while you are saving the data in your database, you have to compute that thoroughly and then you have to persist the data. So that is actually the pros and cons with each of the schema that we have suggested. So with the first approach, though our schema is highly flexible for any type of computation, but here we have to save a lot of volume of the data. But in the second case, though the volume of data is quite less, but before storing the data in our database, we have to do a pre-compute to find out the range and calculation, and then we can simply persist the data. So it is better if you have time, discuss both of this approach with your interviewer and just let him know that what can be the pros and the cons for each and every approach. So here you can see we have captured almost all the data that we need for saving the metadata of the hotel. Now the last and the final thing that we have to capture, and that is the images of the hotel. And to store the images, obviously we will not be storing it in our Postgres solution. Rather, we will be going with a blob storage or with a S3 bucket. I think you are already familiar with this type of approach where we are saving the textual form of the data in our database and we are saving the image or the raw file in our S3 bucket. So here what I will do, I will create another storage called as S3 storage or the blob storage where all the images related to the hotels and the rooms will be saved. I hope this is clear right now that how we are saving the entire information about the hotels, rooms and everything in this hotel database. Now let's see how we will implement this search service, because here if you look carefully, there are a lot of metadata that you have to deal with for searching a particular hotel. And here if you go with a simple solution of searching a hotel based on the location, availability and title, there will be a lot of joins that you have to do over these 5 to 6 tables together to retrieve your relevant search information. And believe me, that will be a very bad solution and your application will be damn slow. So what we will be doing to optimize our search engine, we will take the help of our very efficient Elasticsearch. So here the search service, instead of querying our hotel database, it will query over the Elasticsearch. So what I will do, I will introduce our Elasticsearch over here. So here we will be having our Elasticsearch service, which will actually run all the search related queries and it will retrieve the relevant information to the user. But here if you look carefully, this is not at all simple as it looks like. Because here if you see, in our earlier design, means in our last 4 videos where we were using an Elasticsearch, there the database from where we were pulling the data using the CDC pipeline, that database was a Cassandra or a MongoDB, and there was only a single table on which we were querying. So at that time the format or the structure of the data was quite flattened and it was very easy for us to run our Elasticsearch. But here in this case, our data structure is not like that, because here there are a lot of relational data that are stored in a normalized way. So here we have to find out a way to denormalize all these things so that our query can run successfully and in a highly optimized way within our Elasticsearch service. So let's now see how this Elasticsearch will actually work. Because remember, since this problem statement is quite simple and easy to implement, so these are few of the components that you have to discuss with your interviewer in depth to show that you really understand that how the system should be designed. So let's go in detail of this search service, and that is the Elastic service. So here what we will do, here if you look carefully, whenever a user is trying to search for a particular hotel in our application, the user can search by 2 ways. Number 1, by giving the name of the hotel, or number 2, by giving the location as well as the date on which he wants to book. It is not possible that only by giving the date or by giving the location a user can search a hotel. Because if you go to the booking.com, Airbnb or Make My Trip, you will be seeing that you have to give at least 2 search criteria for searching a particular hotel. So keeping that thing in mind, let's see how this search thing will actually work. So to search a hotel by the name of the hotel is actually quite simple. We can simply rely on the Elasticsearch because our Elasticsearch is highly optimized for doing any type of textual related search. So this thing we can completely rely on our Elasticsearch. No issue with that. But the problem is searching based on the location and the date, because these two are actually a critical way of searching a particular entry in our database. So let's see in detail that how this thing will work. So remember this point carefully, that whenever you are searching a particular attribute in our database with the help of the location, we call it as a proximity search. Means within a proximity of around 5 kilometers, we have to search what are the hotels or what are the attributes that are actually present in our database. And in our system designing, there are 4 best ways by which we can implement a proximity search. So let me list down all those ways of how to implement a proximity search. After that, we will discuss that which is the best approach to solve this problem. So these are the 4 probably the best way to do a proximity search in our database. So the first is the Elasticsearch, because our Elasticsearch is highly optimized for doing all this geolocation search, means based on the geo distance, geo radius. So our Elasticsearch already comes with inbuilt functionality of all those type of search. Next is the quad tree. Now what is the quad tree? I will give you a very brief introduction of the quad tree in this video. Now the next is the Postgres database with the GIS extension. This is again an efficient way of searching the geolocation or the position of the hotels in our database. And the next approach is the geohash. Now let's see in brief what all these things are all about. So since we already know that what is an Elasticsearch and how it comes with all the geospatial searches out of the box, so we will skip this as of now. But we will go to the next one, and that is the quad tree. So what is a quad tree? So if I give you a very brief introduction of a quad tree, so a quad tree is actually a data structure of storing the metadata in the form of the tree. So as you can see, take this as a world map. So our entire world map is partitioned into 4 quadrants. So this will be the northwest, this will be the northeast, and in this way the entire world map is divided into 4 quadrants. Now again, from each and every quadrant, these are again further subdivided into 4 quadrants. So in this way the entire world map gets subdivided recursively into a very small component or small area of, for example, 500 meter. So for example, this is the area of billion square kilometer. Then on the next level, we are making 1/4 of the global space, means we are coming with this 4 quadrant. After that, we are coming with 1/8, and in this way, we will recursively subdivide the world into small quadrant until and unless we reach a very small area of around 200 to 500 meters. And in this way, we keep the information of a particular hotel or the attribute in this data structure. So for example, if I zoom it properly, so for example, you are actually located in this quadrant and you want to search what are the hotels that are available near you. So what actually happens is like the quad tree internally calls all the neighboring quads that are present or the neighboring location that are present. So it will internally call all these 8 location or the 9 location, and it will try to see what are the hotels that are present within this 9 location, and based on that search we have to give the relevant information to the user. I think this is somehow clear that how a quad tree actually works. But this detailed implementation detail of this quad tree we will see in some other video. Maybe when we will be implementing a taxi booking application like Uber or Ola. There we will also see how the proximity search will actually work. Because at that time it will be a very critical functional requirement for Ola or Uber that how you will find the nearest driver based on your location. So at that time we will go in detail of all the proximity search that I have mentioned over here. But as of now, I will just give you a brief introduction of each and every one, and I will just tell you which is the perfect one for you for this use case. So now let's go to the next one, and that is the PostgreSDB. So this PostgreSDB with our GIS extension is another way of efficiently searching our database. So here if you look carefully, here we are using a PostgreSDB, and with the GIS extension, it is actually nothing but a way of indexing so that we can index this geolocation properly so that our geo search engine can work efficiently. So that is the next one, and the last and the final one is the geohash. So the geohash concept is more or less the same just like the quad tree, but it is actually implemented in a more efficient way than the quad tree. So I think you got a brief introduction or a brief idea that how this 4 proximity search actually works. Now let's see which one we should implement in this use case. So here if you look carefully, whatever the data we are dealing with are all static because obviously a hotel cannot move, right? So hotel data or the geolocation of a particular hotel will be obviously a static one. So that is a very important key point to note that our data is static. Now if you go into the detail of the quad tree, how this quad tree actually work is like quad tree is not a database. It is a data structure that we have to save in a local cache to query on each and every time. Means for example, we have a million of record in our database of the hotel. We have to take all the geolocation of those 1 million record into a local cache. We have to create a quad tree or a data structure like quad tree in our local cache, and this search service have to search for the relevant hotel from that quad tree that is saved in a Redis cache or something like that. So that is the main way how we actually use a quad tree in our design. But if you understand this point correctly, that is, quad tree requires a lot of space to create that data structure. Because here if you see, we are dealing with the millions of record of the hotel, and all those millions of the data of the hotel will come into our cache or a local memory, and there we have to create the quad tree out of that. So that will be an extra space that we have to use to implement this type of proximity search. Now going with the third approach, here you can see, here we are also using the Postgres. So here we are not have to use an additional data structure or additional space to implement this proximity search. And similarly, same thing happens for the geohash. But the main critical problem for this use case is that here, if you look carefully, we have to do a searching operation for both textual search as well as the location search. So the textual search is actually quite important, and none of the proximity search other than Elasticsearch support a textual search. Means a query doesn't support a textual search, or Postgres solution with the GIX extension doesn't support a textual search. Similarly, our geohash doesn't support a textual search. So blindly we can simply go with our Elasticsearch, because for this use case we need both the location search as well as with the name search. So since we need both of them, we have to go with the Elasticsearch. So I hope this is clear that based on all these 4 algorithms, why we are going with the Elasticsearch for implementing the proximity search. And remember this point clearly, just because you know all these things doesn't mean you have to always go with all this complex solution to solve such a simple problem. Because I have seen in lots of YouTube video that to solve this simple problem, they are going with the query or some other approach. They are right, but this is quite a simple solution. And here, since we are going with 2 of the search criteria, that is the text-based search as well as with the geolocation search, so choosing a query will not be an efficient solution. Rather, we can simply go with the Elasticsearch, which gives all the searching logic on the geospatial index by default. And just to give you an idea, internally this Elasticsearch actually uses this geohash to retrieve all the relevant information. So here what we are doing, we are going with the Elasticsearch. I think this is clear that how we will be searching the hotels based on the proximity or based on the location. Now let me tell you what are the other problems that can come up since you are using a Elasticsearch over here. So the problem that can happen for the Elasticsearch is, as I was telling you, when we are using the Elasticsearch for our earlier video, the database that we have was a flat database, means it was either a Cassandra or it was a MongoDB. But in this case, since this database is not a flattened database, so there are a lot of internal joins that we have to do to search a relevant information. So I will suggest you 2 ways over here also how we can optimize this searching algorithm to find a particular hotel based on the location, title and date. So let's see what we will do. So as you know, whenever we are introducing an Elasticsearch, obviously we have to ingest all the relevant information of the data in our Elasticsearch. And for that, normally what we do, we simply use a CDC pipeline to ingest the data. But since here in this case, our data are not flattened, so we cannot go with a simple CDC approach. Here, along with this CDC pipeline, here we have to write a consumer service, means the consumer service that is related with the CDC pipeline. On top of that, we have to write an algorithm to denormalize all those data. So what will happen? Whenever a new data comes to our database, we have to first denormalize all this thing, means we have to do all those joins together. And then once we are done with all those joins, we got a flattened result, and that flattened result we will insert it in our Elasticsearch, so that whenever a user is doing a search operation, we can easily get all the relevant information in our Elasticsearch. So that will be our first approach. That is, within this CDC pipeline, we have to write a logic to denormalize all this data and store it within the Elasticsearch. But if you see, with this approach, there will be again a problem. That is, this Elasticsearch will have a too much data which is actually not needed. Because for example, once the user is only searching with the hotel name, we do not need all this information like what are the rooms that are present, what are the size of the rooms, what is the availability. All those things are not needed while he is doing a search based on name. So here also we have to think a bit how we can optimize this Elasticsearch so that our Elasticsearch doesn't get overwhelmed with all those irrelevant data that are not necessary right now. So here I will propose you with the second solution, and that is, here we will go with the 2-phase search query. That is, this Elasticsearch will be fed with a single table, that is this hotel table. And this hotel table obviously have all the information of the name, the geolocation and everything. Means whatever the search a user wants to do based on the title or the location, the Elasticsearch will get it from here. Now once the Elasticsearch gets all the relevant hotels that matches a particular criteria, what we have to do, they are based on those handful amount of hotel ID, we will simply create a join in our search service and then we will send the response to the user. So what we are doing, for example, here we have a millions of record in our hotel database and you want to search a particular hotel, for example, in Bangalore on a particular location. So from this millions of record based on Bangalore on a particular location, we will be getting, for example, hundreds of records out of that. And on those 100 records, means those 100 records that we got in our search, we will do a join on this price, room and availability table, so that we can see that what are the rooms that are available for those hotel on that respective date. So here what we'll do, to do this join operation, I will introduce another attribute and that is a Redis cache over here. And this Redis cache will have only the information about the rooms, the price of the rooms and the availability. So that once the Elasticsearch returns with a handful number of hotel ID for a particular location, we can simply do a inner join with all the tables that are present on our Redis cache. And since this is a Redis cache, so obviously our search should be highly optimized and we can simply give all the meaningful data to the user. I hope you are clear with how we are actually implementing this search service in our application. So here one more thing I forgot to mention, that this search service will also talk with the S3 bucket that we have defined to store all the metadata of the image. Because obviously while we are sending the response to the user, we have to also send the relevant images for that hotel. So this is how our search service will work. Now since we have discussed a lot of things about the search service, let's now implement some of the easier thing, that is the review service and the booking info service. So very obviously this will be a simple implementation. So here we will be having a review DB, can be a Postgres DB, it can be MySQL, it can be a Cassandra, anything you want you can take it for the review database. So I'm just taking a MySQL database over here also, and let me show you what will be the schema structure. So this is how the schema structure will look like. So here we have the hotel ID, the user ID who is posting the review, the rating of the hotel, the comments as well as the images the user is uploading. So all these things will go into our review DB. And remember one thing, here also all the images that the reviewer is uploading will go in our S3 bucket. I think this is clear. So here all the images of the review, we are saving it within our S3 bucket, and all the metadata of the review we are storing in this review DB. Now, before going into the booking info service, we have to talk about the booking service, because booking info service is quite simple and it is highly dependent on the booking service and how it is working. So let's start with the next important core concept of this system design, and that is the booking service, where we will see in detail that how we should maintain the consistency in the system so that no two user can book the same hotel on a same period of time and so on. So let's start with the deep dive analysis of this booking service. And here, since booking service need a lot of detail, what I will be doing, I will be just reorganizing this over here so that I just get some enough room to expand these services. So here I have just reorganized all the services so that I can get some enough room to elaborate. Now here, if you look carefully, we have the booking service. And if you remember, when I was explaining the API designing, I told you that the booking is a two-step process. Number one, once a user tries to book a hotel or book a room, first he will be landed to a confirmation page or a payment service where he have to put all the payment related details like the card details, OTP and all these things. And once he confirms the payment credentials, then the payment service will internally call a third party payment gateway where the actual transaction will happen with the bank, and based on the result or the acknowledgement from the bank, we will tell that the confirmation or the booking is successful or not. So here if you see, we have the booking service, and from this booking service we have to call another service called the payment service. So what we will do, I will create another service over here called as the payment service. And this payment service will capture all the details of your payment. And here if you see, this is a third-party payment gateway where the actual transaction will happen. And once the transaction actually happens, what we have to do, we have to actually log that payment. Means we have to process that payment related information into our DB. And for that, what we will do, we will be having one more DB called as the payment DB. And as you know, payment DB should be highly consistent and highly available, and that is why we will simply go with our MySQL database. So let me quickly mention all those details. So this is how the schema for the payment will look like. So obviously there will be a user ID who is actually making the payment. There is a booking ID for which we are making the payment, the amount, currency, and the date when the payment took place. So these are the attributes that we have to store in our payment DB. Now, once the payment is successful, what we have to do? We have to update our hotel DB that one of the rooms or the couple of the rooms got allocated for a particular date. So that is one of the activity. That is, we have to update the hotel availability DB. And number two, we have to send notification to the user that your booking is confirmed, and this is all the detail. And since this booking service have to do all this related thing concurrently, so it is better we should go with the event-driven services. Means instead of updating this hotel database and the booking database together by these booking services, what we will do, we will introduce a Kafka broker so that once the booking is done, we can throw an event in our Kafka broker, and from there the respective services will get updated. Otherwise, what will happen, since this is a two-phase commit that we are doing over here, means it have to update both the booking DB as well as the hotel database. So in case one of this updation gets fail, there will be an inconsistency among all the services. And to maintain the consistency of the services, we are going with the event-driven services where the event will be placed in a Kafka broker. So here what we will do, we will remove this two updation from here, and instead of updating this booking database by the booking service, we will introduce a Kafka services over here. So here, once the payment is done, the booking service will update the Kafka service that a particular booking has been done. And thereafter, once the event is there in our Kafka broker, we have to do two things. One, we have to send notification to the user, for which we will be having another services called as a notification service. And there will be one more consumer service who will be consuming this event from the Kafka, and it will just update the booking database. So here we will be having a consumer service, and the responsibility of this consumer service is to update the booking database. Means the booking has been done and this is the status of the booking. So I think this is clear. So what is happening, once the user comes to the booking service and click on confirm, the booking request goes to the payment service, and thereafter the payment service make the payment using the payment gateway, and based on the successful or the failure, it updates the payment DB with the corresponding status, and once the payment is successful or failed, it sends an acknowledgement to the booking service, and this booking service will generate an event in our Kafka broker. And once an event gets generated in our Kafka broker, what it is happening, there are a couple of consumer service who are updating the respective DB individually. So here we have the notification service which is sending the notification to the user, and here we have the consumer service who is just persisting the booking related information in the booking database. Clear? But there is one more action that is left, that is updating availability table in our hotel DB. And for that, what we will do, we have to write one more consumer service, which I will name it as the availability service. And this availability service will have some other responsibility to do. But let me right now just create the availability service, and I will tell you what are the roles that it have to perform. So here we will be having one more service called the availability service. So here we have the availability service, and the main role of this availability service is one thing, that is update this availability table. That is the only thing this availability service should do. No other service should be responsible to update this availability DB. Otherwise, there can be a consistency issue. So what we will do, this room availability service will update this hotel DB, and it will update this availability table that a particular room got allocated or a particular room got booked for this amount of time. So this is the core responsibility of this availability service. So I hope this is clear how we are using each and every microservice to update each and every database over here. So I hope we are already done with all the requirement that we have gathered. But there is still a major functionality that is left, a major non-functional requirement, that is we have to design our system in such a way that no two user can able to book a same room. And when this scenario can come, this can only come when two or more users are trying to book a same room on a same date range. So that is the only time this scenario can occur. So let's see how we can solve the problem of the concurrency control. So if you look into this complete flow, you will see there is a flaw. That is, whenever a user is trying to book a room, here the booking service is just redirecting the user to the payment gateway without checking that whether the room is available or not. So here let's take an example that there are two users. One user is trying to book at the 0th second and another user is trying to book the room at 0 plus 5 seconds. And since at the very initial state the rooms were available on the search result for a given time frame, so both the user have seen that the rooms are available. So here in the first case, the user 1 is trying to book the room at the T0 time. So the request comes to the booking service and thereafter it gets redirected to the payment gateway and so on. And once the payment is done, the booking has been confirmed. Now for the second user who is coming on T plus 5 second, for that user also in our booking service, the room is still available because this booking service have not got the updated detail of the booking that the first user have done. So here there is a major inconsistency on this system. So what we have to do before we redirect a user to our payment gateway, we have to make another verification into our database that whether the room is still empty or not. So here from this booking service, we will make an additional check to the availability database. And for that, what we have to do, we have to call this room availability service. And this availability service will check that the room is empty or not. And if it is empty, means it is ready for availability, it will give a green signal to the booking service and thereafter it will move to the payment gateway. Clear? So right now our first problem statement is solved. Means once the second user comes on T5 second, the booking service will check that at the 5th second whether the room is still available or not. And here it will see that it has already been booked by the user 1. So it is not available and it will throw an error to the user that that room is not available for the given time frame. So we have solved the first use case when the two users are trying to book the same room almost concurrently, but not concurrently, because here you can see there was a difference of 5 seconds between the two booking transactions. But what will happen if both of them try to hit the book services almost at the same time? So what will happen? For example, for that case, the request of the user 2 comes before user 1. And once the request come to the booking service, what booking service have to do? It have to lock or hold that room for that corresponding timestamp. So that until and unless this user 2 doesn't make the payments and confirm the booking, no other user can book the same room. So what we will do, here we will be using a Redis cache or a Redis log to hold a lock on a particular room. So this implementation is more or less same the way we have done the ticket booking service. So in the ticket booking service, I have explained you in detail that how we are using this Redis log to book a particular ticket on a given time frame. Similarly, over here also we are following the same thing. So that is why I will just here give you a brief introduction that how we will solve this problem, because more or less these are the same approaches by which we will solve both the problem. So if you have not gone through that video, I will highly recommend you go through that video first and then come back to this video, because more or less both the concept are same. So here we are having the Redis lock where we are locking a particular room for the user and the time frame will be around 5 minutes. Means the total amount of time it might take for the user to make the payment. And here you can see I have given a TTL on this Redis lock. Means once the 5 minutes has been passed and the booking is still not done, what the Redis lock will do, it will delete this record from this Redis. And thus the room will be again available for booking. I hope this is clear because this is more or less the same concept of the ticket booking application. So I hope we have fulfilled all the functional as well as the non-functional requirement that we have gathered during our initial discussion. So here you can see all the functional requirement has been fulfilled, as well as we have also fulfilled all the non-functional requirement. And obviously, since this is a microservice architecture, so here all the service will scale accordingly based on the traffic. So our system is highly scalable, consistent and available, and I think it will fulfill all the requirement that we have gathered. So I think it is clear. Now the last but not the least, we have the booking info service, which simply iterate over our booking database to fetch all the bookings related to a particular user, and that's it. This is a very clear, straightforward implementation. Here I will just mention you one more thing, that is what will be the schema structure for this booking database. So this booking database will have this following schema structure. So this is how the booking schema will look like. So here also we are using a Postgres or a MySQL database. And here we will be having the booking ID, which will be the unique key over here. Then we will be having the hotel ID, the user ID, the list of rooms he is booking. So obviously it might can happen that a particular user is booking more than one room. So here we will be having a list of rooms that a user is booking. Then we will be having a start date, end date, amount, currency, status, and all the other metadata that is required. So this will be the schema structure of this booking database. So I hope you have thoroughly understood this video and you have found this video useful. And if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my channel and you are always ready for your next interview. So see you on our next video where we will be solving another problem on system designing. So see you on our next video. Thank you.